Well, hello Internet and welcome to my Groovy video tutorial. In this tutorial, you're going to learn pretty much everything you'd like to know about the Groovy programming language or what you would normally find in a 250-page book in one video. In the description underneath the video, I have a link to all the code as well as a transcript for the video and also timestamps so you'll be able to jump to whatever you want to learn about. And I have a lot to do, so let's get into it. Okay, to use Groovy, of course, we're going to need Java. So you're going to want to go to java.com and download at least Java 7, or of course you can use Java 8. And this is going to be true if you are on a Mac or you are on Windows. Also, if you are on Windows, you're going to want to go to groovy-lang.org, download, and then just click on this Windows installer down here and click next a whole bunch of times, and then you'll have Groovy ready. And the rest of this tutorial is going to work in regards to whether you're on a Mac or you are on a OS X machine or a Linux machine. Now, if you are on a Macintosh, you're going to want to go to brew.sh and you're going to want to install Homebrew if you don't have it installed. And how you install it is you just copy this guy right here, and then you open up your terminal and paste it in there, hit enter, and that's going to install Homebrew. Now, we're going to have to do a couple other different things here. Also in the terminal on OS X to get Groovy all set up here for you. Now, more than likely, your Mac's going to have a bunch of different versions of Java installed, so you want to make sure you're using at least Java 7 for Groovy. That is a must. So inside of your terminal, you're going to type in this line of code you see right here and hit enter, and then you're going to pick whatever the latest version of Java is on your machine. I have 1.7.0_55. You're going to want to copy this. And then inside of your terminal, you're going to want to type in export Java home exactly as you see right here. Again, I have this code in the description underneath the video if you want to just copy and paste. Just make sure you put a backslash right here or a back quote right there. Everything else will be the same, and this guy right here is going to be what we copied from what we previously did in the terminal. And then you're going to want to hit enter, and then you're going to want to verify that you are using at least Java 7, like I said. So you're going to type in Java-version, and you can see right there that I have Java 7 set up. Then to install Groovy, you're going to, once again, you're going to need Homebrew, like I mentioned previously, and then you're going to type in brew install Groovy, and I already have Groovy installed, so it's just going to tell me Groovy's already installed, but you're going to get a message that's going to say that it's going to install Groovy, and then after you do that, you are ready to go. Now we get to the part where we're going to set up Atom. This is the text editor that I'm using right here. You can use whatever you want to use, but I just want to show you how to install a Groovy package. It's going to make the text look a lot prettier whenever you're typing in your code. So what you're going to want to do in Atom is go to Packages and Command Palette. Click that guy right there. You're going to want to type in install like this. Look for install packages and themes and click on that. And then inside of this guy, you're going to want to come in and type in language. And this is on Windows as well as on Mac, and Groovy. And whenever you do, it's going to open this guy up, and I already have it installed, but you're going to see a blue install. You're going to click on that. It's going to install it, and then everything's going to work. Okay, so we have Java as well as Groovy, as well as the tools that we need for Atom to be able to write some good Groovy code. So now I'm going to start writing some code. Alright, so what I'm going to do here is create a whole bunch of different files. This one's called groovytut.groovy. Groovy is the extension. And I'm going to create a class right here. And I'm going to call this groovytut. And then where all your code is going to run is going to be in the static void main string args. And I'll show you what, or I'll tell you what all this stuff means. Static just means that this is a method or function that belongs to the class. Void means that it doesn't return anything whenever this function runs. Main means this is the main executable function that is going to execute whenever you call for this file to execute. And this right here is a string array that's called args. And on the terminal, if you would call this program and pass in a bunch of strings or numbers or whatever, all of those are going to be stored in this string array. So that's everything that goes on right there with main. So now what we're going to do is create a hello world thing. And to do that, you just type in print line. What this is going to do is come in here, print out whatever text you put inside of there, and then follow that up with a new line. To run your Groovy code, you're going to come in and type in groovy, groovytut.groovy, and hit enter. and it's going to run. And there you can see hello world. And you're going to be using the command prompt instead on Windows, but everything else is basically going to be the same. Now you're going to be able to define variables or fields or whatever you want to call them by typing in def, D-E-F, and then you're going to start your variable name with a letter, and then you're also going to be able to use numbers or underscores for the rest of the variable name. Now variables are going to be dynamically typed, so what that means is we would be able to come in here and define a variable called age and give it a string name like that, and then come in and give it an integer value. A lot of programming languages wouldn't let you do this, but Groovy says that's all perfectly fine. So let's do some basic mathematical operations here. And here are some basic math functions. So I'm just going to use print line once again. You can see here how you add, how you would subtract, how you would multiply. This is going to be using integer division. I'm going to show you float division or division with numbers that have decimal places, and this is the modulus, and what this is going to do is return the remainder of a division. Over here, execute it, and you can see exactly how those all work out. Now let's take a look at floating point math operators because they are different. And here they are, and you can see how they actually differ. Here, if you want to do addition, and this is for floating point numbers, you're going to follow this with a dot and plus and whatever you want to add to it. And there's your number followed by minus, and there that goes, and multiply. And here you can also see division, and this is the difference between division with floating point numbers and division using regular integers. Now order of operations is going to work in Ruby just like it works in most programming languages, and that just means that whenever you put a multiplication somewhere inside of your operation you're trying to perform, that the multiplication, no matter what the order is here, is going to take place if you don't use parentheses, and then the addition unless we put in parentheses. So let's come in here and we'll see exactly how this all works out for us. So we'll say 3 plus 2 times 5. And then we'll come in and we'll see the differences between putting the parentheses inside of here as well. And all you need to really think about is the fact that whenever you are putting a multiplication in here and you're not using parentheses or divisions, that those are going to take effect, or those calculations are going to be performed before the additions or the subtractions. So that's just a little bit to know about order of operations and how that works out for us. Now we're going to be able to come in here and use shortcut increment as well as decrementing of values for our variables. So let's take age here, and that is going to add 1 to age. And you're going to see here the difference between putting the pluses before versus putting them after, like we have right there. And then copy and paste that in. So let's come in and move this from right there to right here and put the pluses right here. And all this is doing is adding 1 to age. And then we can also decrement shortcut like this. And then we can, of course, decrement at the beginning. Now what this is going to do is, in the situation in which the plus comes after, what it's going to say is, I want you to print the value of age as it is, which is equal to 40, as you can see right there. And then after you print it to the screen, then I want you to increment the value of age. So after this line, age is going to be equal to 41, even though 40 is going to print right here. And there you are. You can see that 40 printed out. Why? Because it gets the value of age before we increment it. And you can see in this situation, whenever you put the pluses ahead of time, that it's going to first add the values. Remember, it's 41 already right here. And then afterwards, it's going to add and then print, and that's the reason why it's 42. Likewise, age is going to work the same way. It's going to say, hey, print out the value of age and then decrement it. And here it's saying first decrement it and then print out the value of age. So that's like a shortcut way that we can increment and decrement values. It's very easy to figure out how we can come in here and take a look at the largest integers as well as the largest floats and the largest doubles inside of Groovy. All you need to do is type in integer and then followed by max value, float, max value, min value, double, so forth and so on. And every single thing, if I didn't say this before, inside of Groovy is an object. So even age in this situation is an object, and also all these other different guys. And you're going to see the maximum value. So the biggest integer is going to be that number. The smallest integer is going to be this. The biggest float is going to be this number, and so forth and so on. And as you can see, these guys get quite big. And also, unlike some programming languages, the decimal accuracy is very, very accurate inside of Groovy. So there you go. That's a great big giant number. Let's come up here and let's do a view and soft wrap so you can see everything. So what I'm going to do right here is I'm actually adding these gigantic numbers together. You can see how long they are. And there that is, and there that is. In some programming languages, this would not properly add. However, as you're going to see with Groovy, they add perfectly fine. And if you go and analyze these, you can actually see that yes, indeed, this calculation, this is actually wrong here. Then I'm adding numbers that are way bigger. But you can see that you can actually very accurately perform decimal calculations inside of Groovy and know that they're going to work out for you. So there that is, and that's very important as well. In regard to math functions, let's come in here and define another number. So we got random number, and let's make this a floating point number. And floating point just means it has a decimal. Sounds complicated, but it isn't. And let's go and show you how absolute value works. And we'll say math to get the absolute value, absolute, and negative 2.45. It's just going to go and get rid of that negative sign. And there you can see right there. And just to save ourselves some time, let's go and take a look at all these other different operations we have here. We can round. Basically what this is going to do for us is this is 2.45, and whenever we round that, since it's under 5, it is going to round downwards. If this 4 was a 5 instead, it would round upwards. So that's how round works. Power, it's just going to take whatever the value of a random number is and take it to the power of 3 in this situation. Here we are checking equality between these two floating point numbers with the function equals. Here we can also come in and check if the value or the data type of random number is a float. See here how we can find out what the square root of 9 is, how the cube roots, the ceiling. What this is going to do is raise this to 3. Floor is going to drop it down to 2. Minimum is going to receive 2 values, and it's going to kick back whatever the minimum value is, and max is going to do the opposite. And if we run this, you can see all of those operations and exactly how those work out. And it might help you to click on pause every once in a while to take a closer look at what's going on here, or just move along at your own speed. We have other operations we can perform. So we can come in and do a log function as well. So let's go and get math. We could do regular log or log 10, so we can go log 2, for example. And to get the value for that, you just go math.log 2 to get that value. And that is just going to be whatever number you provide to the power of e. And you could also come in and do log 10. This is just a base 10 logarithm. And that's how that differs right there. We're also going to be able to convert from radians into degrees and degrees into radians just by calling 2 degrees or 2 radians and the calculations you have right there. Also, we're going to have sine, cosine, tangent, arcsine, arccosine, arctangent, and so forth and so on. And that is how easy those are going to be able to use those functions. And then finally, I'm going to take a look at creating a random function, or a random value. So I'm going to go math and absolute value, and I'm going to say new random, followed by next int and the percent sign and 100, and then outside of that I'm going to add 1 to it. And if you do this, what you're going to do, or what you're going to get in exchange, is you're going to get a random number between the value of 1 to the value of 100. And let's come in here and verify that all that works perfectly fine. I'm just going to come in here and copy this guy right here, throw some parentheses inside of there, throw that right there, put that right there, execute this, and you're going to see that it kicks back a value of 93 for that random number generation. Come in here, execute again, now it's 24, and now it's 68. So there's a rundown of a whole bunch of different math operators that are available for us with Groovy. Now I'm going to take a closer look at strings. Now, as per strings, let's go and create a string. You can see that it's just like this, and I can type in my name, for example, and there you go, it's a string. But remember, we can throw integers inside of there just because Groovy is dynamically typed. Now, there are a couple different types of strings. Let's go and create a print line. Let's put single quotes. Now, whenever we have single quotes, what it is going to do is the string inside of it is going to be taken literally. That means that if we come in here and we say that we want to put in a variable like this, the variable is going to be completely ignored. However, the backslash or the new line is not going to be ignored. Now let's go and take a look at how that differs with if we would come in here and put in double quotes. So we'll throw double quotes inside of here, and we'll jump over here, and you can see in this situation, name comes back as just exactly what we typed, but there is a new line, and here you can see that the value or the variable actually changed. And also you can see that I don't need to put these curly brackets here. I can also leave those off. It's just a convention that sometimes people put those in there and sometimes they don't, and I just want to make you aware of the differences. Now there are other types of strings. We could also use a triple quoted string, and this is used for a multi-line string. So let's go and create this, and it's just, there you go, there's triple, and I could say something like I am a string, and then I'm just going to close that off with a triple string, and then of course whenever we print this out, we go multi-string over here, execute, and it's going to actually print exactly as you typed it in on the keyboard across multiple different strings. And you can see if we put that there, close that, and execute, that it comes out exactly as you put it. Now you're going to be able to access your string by indexes. We could say something like, let's say we wanted to get the third index of name. Each of the string, or each of the letters in the string, or whatever it is, characters in the string, is going to be stored in an index. Here I want the third one to show up here. And let's also say that I want to get the index based off of a letter that is inside of it. Could also do that. So let's say, get rid of this, and we could say something like index of R. And to get that guy, we're instead going to say name, index of, and then type in exactly what we're looking for. And if we execute it, the third index of the name is E. How did we get to that? Well, 0, 1, 2, 3. So that's the third index. And here we're asking for the first letter R that is found inside, and you can see that 2 is returned, and that's 0, 1, and 2. You're also going to be able to come in and get a slice. So let's go. I think I can do this. There we are. Let's say that I want to get the first 3 characters of a string. I can come in and say first 3 characters. I can just go name, and then inside of this I'm going to say 0, and I'm going to put 2 dots and a 2, and that's going to return those first 3 characters. I can also get a specific characters, so I could come in and say every other character, and instead of that I'm going to type in, instead of 3 anyway, I'm going to type in 0, 2, and 4. I can get all those. You can see there that I grabbed them. Say I grabbed the first 3 characters in this situation, and every other character in this situation grabs DRK from my name. I can also get characters starting at an index. So this would be considered a substring. So I want to get a substring at 1. I'm going to say name dot substring starting at 1. And you can see it skipped over the very first index and printed out everything else. I can also more specifically get characters at a starting index up to another starting index. So here we're going to say, well, let's just change this guy here instead. We'll say a substring at 1, 2, 4. And to get that, we'll just say name, substring, leave it exactly the same, and then start this off at 4. And you can see it just grabbed the ERE out of my name. We can come in and concatenate strings quite easily. So let's say we want to just say my name. We can concatenate these guys with the plus sign. So we can just put name inside of there. We could also come in and concatenate with the concatenate function. Either one's going to work exactly the same. And in this situation, we'll say my name and put dot concat and name, and both of them do exactly the same thing. Could also come in and repeat a string multiple times. So we could say something like what I said is, and then come in here and put a multiplication sign and 2, and that's going to double up the printing of that string on your screen. We can also check for equality. Does Derek equal Derek? And then check for equality by saying Derek followed by equals, and then put the same exact thing inside of there. And let's copy this and let's do something else. We can also check for equality and ignore case. So here we'll say Derek, and then we'll change this to a lowercase d, and we'll say equals in this situation, ignore case, and then also change this to a lowercase d. And you can see both of those come back as true. We're going to be able to come in and get the length of a string. So we'll say length, and we can just throw a name inside of there, followed by length. and that gives a total length of our string, or the number of indexes, or the number of characters inside of it. I'm going to throw the repeat string inside of here again, so I can just have a longer string that I'll be able to do some things with. Let's say I want to remove the first occurrence of the word what inside of here. I can just go repeat string minus, and what I want to remove from it. Could also split the string. So let's do a print line here, and repeat string, and split. And what I want it to split on are going to be the spaces inside of our string. And also we can come in and go repeat and do exactly the same thing. Repeat string, convert it to a list, and you'll see how those work out. Here we went and split it with all the different spaces, and here we actually went in and split it based off of every single character in the entire list, or in the entire string. We could also come in and replace all strings. So we'll go repeat string and replace all. And let's say that I want to replace all occurrences of the word I with the word she. Easily enough. You can also, with a simple function, come in here and print all the characters in both uppercase as well as in lowercase. And there you can see, printed that in uppercase, printed that in lowercase. And you can see here where we replaced I with she across the entire string. And then finally, I'm going to show you this operator right here that allows us to compare strings. Let's go print line and ant, throw that operator in there. And let's say I wanted to compare ants to bananas. I can come in, go ant and banana. And what this is going to do is this is going to return -1 if the first string comes before the second. It's going to return 1 if in the opposite situation, and it's going to return a 0 if the two strings are equal to each other. And we can just come in here, change this to banana instead of ant, and then down here change this to ant and change this to ant. Come in here and run, and you can see exactly how that works out. We get a -1, we get a 1, and we get a 0. So there's a rundown of pretty much most of the things you can do with strings inside of Groovy. Now I'm going to take a look at input and output. Now, like I said before, with double quotes, we're going to be able to insert variables inside of our strings. So let's go and create a new string here. Let's call this a random string, and let's just throw the word random inside of here. Print line, and we're going to be able to say random string with the $, and you can see it and automatically took the random value and juxtaposed it directly inside of there. You're also going to be able to do the same thing with another function that is called printf, but you're going to do it in a different way. So here we're going to throw a string inside of here, and then in this situation you're going to have to put a new line inside of there because it doesn't have one inside. But then you're going to have to put the string that you are referencing on the outside. And you're going to be able to do the same thing with multiple different values with printf. So let's come in and do something a little bit more sophisticated. Let's say that we want to put a string inside of here, but we want to have some spaces inside of it. We can go and put a -10 inside of there, and you're going to see what that does. You can throw a decimal or an integer number inside of here. We can also come in and throw a float that has a maximum of 2 decimal places. Again, we're going to throw a string inside of here that's going to have some padding. And in this situation, we're going to actually create a list with all the different things we want to put inside of here. So we'll say stuff and 10 and 1.234, and then the word random. Execute. And you can see right here, whenever we put a negative inside of here, it's going to put some padding on the right side. If we have a positive number here for the string, it's going to put some padding on the left side. You can see here that it went and just printed a regular old 10 because there's nothing fancy going on here. And here it went and trimmed down the floating point number from 1.234 to 1.23 because we said that we only wanted 2 decimal places to show. So there's a couple more different ways to output data. Now let's take a look at inputting it. Let's say we wanted to allow the user to come in and enter their name. So we'll say something like, what's your name? We're going to be able to get that name that they enter in the terminal by going system console followed by read line. That's going to read that input that they sent to us. And then we can output that information on the screen, of course. So we'll say something like, hello, fname. And it'll say, what's your name? I'll say Derek, and it'll say, hello, Derek, very politely. Just remember, you're going to have to cast the input to the right value to be able to use it. So let's say we come in and we'll say print, enter a number. And here we'll define a variable. We'll call this one number1 is equal to system, because everything that is entered in on the system is going to be a string by default. So it needs to know that you want it to be converted from a string into a double before it can perform any type of mathematical calculations. And likewise, we're going to ask them to enter another number. So enter a number, let's just leave it that way. We'll change this to 2. Everything else is going to be the same. We're going to convert this to a double. And then we're going to come in and do a print f. Let's go just to reinforce how this works for us. We're going to say that we only want 2 decimal places, and another 2 decimal placed floating point number is going to be equal to, and another one, 0.2 floating point number. And we're going to go and create a list. Let's just create it on the next line so it's a little easier to see. And here we'll just say number1, number2, and then perform our little calculation, and we'll say number1 plus number2, and there we go. It's going to say what's your name. I'll just say Derek. I forgot to take that part out. Enter a number, we'll say 1.2. Enter another, we'll say 1.2, and 2.4 comes back. So that's how we can work with output as well as input inside of Groovy. Now let's take a look at lists. Now a list is just going to hold a list of objects with indexes for each different object you have inside of your list. So I'm going to create primes here. So there's just a list of prime numbers. You're also going to be able to put strings and numbers or whatever you want inside of there. We're going to be able to get a value at any of these different indexes inside of here. So let's say that we created this and then we wanted to get the second prime in our list. Easily enough, we can just go primes and 2, and we can get that. We could also, in a different way, if you want to know multiple different ways to do things inside of Groovy, well, you're in the right place. We can just leave this be third prime instead, third prime, and we'll say primes in this situation. However, we're going to say get, and it's going to be index 2 in this situation. Let's say this is actually going to be index 1. So here we're getting the second prime, here we're getting the third prime. And you can see that those come back as 3 and 5. Like I said before, your lists are going to be able to hold anything. So let's say I create one called employee, and it's going to have a string inside of it. It's going to have an integer inside of it. It's going to have a floating point number inside of it, and it's going to have a list inside of it. We're then going to be able to come in here, and let's say we wanted to get the second number of the list that is stored inside of our list. Just do it this way, and we'll say employee like that, and we want to get the third index, and then from that list we want to get the first number or the second number from it. And there you can see that we were able to do just that. We're going to be able to also come in here and get the length of this guy. So let's just come in here. Let's get rid of some of this stuff. So let's come in and let's get the length of it. And to get that, you just go primes and you follow that up with size, except you put a dot inside of there and you put 2 closing parentheses there. We're going to be able to add an index as well. So we can say primes and add 17. We'll be able to append to the right another one of these guys, and to do that you use this little funky thing, and let's say we want to throw 19 on there. You can also go and put in primes add. It's going to do exactly the same thing as that funky operator, and we could throw 23 inside of there. Likewise, we would be able to concatenate 2 lists, so we could say something like primes and then throw in 2 more numbers. We could remove the last item from our list by going primes dash and 31. We'd be able to check if it is empty, if our list is empty, and we'll say is empty and say primes is empty. Don't forget to put this little dot inside of there. There you are, because that is a method or a function that we're going to be calling. We'd be able to come in and get, let's say, the first 3 items inside of our list by going primes, and we'll put in a 0 dot dot 2, so we're getting a slice out of there. And we can come in and print out the whole entire thing, and there you can see the entire list based off of all the additions and changes that we made to it. We're also going to be able to come in and get matches, so we can say, well, we have this one list and we want to see how it matches up with another list. No problem. So we'll say matches, and then we'll say primes and intersect based off of another list, and this list is going to be 2, 3, and 7. We'll be able to easily reverse our list by going reverse and primes and calling the function reverse. Likewise, we'll be able to sort our list just by putting in sort instead of reverse. And that's going to sort it in alphabetical order. I mean, technically reverse sorts it as well, so just sorting it in a different way. And then finally, the last thing that I can think of that we can do with these guys is pop off the last item. And how you pop that off is by typing in pop. And if we come in and we run that, you're going to see all the different things we did right there. So there you go. That is a rundown of all the things you can do with lists inside of Groovy. Now let's take a look at maps. Now a map is very similar to a list. The only difference is a map is going to contain a list of objects with keys versus just regular old numbers that are indexes with lists. How you create one, DEF again, and let's create a Paul map that has information about Paul. And here is the key. So we got the name and then follow it up with Paul's name. You're going to be able to store all sorts of things inside of here. We're going to be able to go age and say that Paul is 35. We're going to be able to put an address or a string inside of here and say 123 Main Street. And then finally we can also put a list inside of our map. And this is just going to be 1, 2, and 3. So there you go. You just created a map, and don't forget to put your semicolon there at the end. You're going to be able to access your map with a key. So let's come in and do a couple different things here. So let's say we wanted to get name. We can come in and just type in Paul and map. And here you're going to put in go like that. You're going to put in the key that you want to search for. You're also going to be able to get this in a couple different ways. We're going to be able to use a function called get. So let's say we want to get age, and in this situation we want to get age using the get method. Just go get and then throw age inside of there. And let's also show you how to get a list item. So let's just go and get rid of this guy and say we want a list item. We're going to go Paul map, and you're going to type in list instead, which is the key that we are searching for. And then you want to get second item inside of that, and because it's 0 index, the second item is going to be 1, and you can see that we were able to go in and get all those different things. We're also going to want to be able to come in, of course, and be able to add keys, and to do that we just go Paul map and put, and whatever you want to give the key name for, it's going to be city, and let's go and say Pittsburgh, just because the first thing came to mind. We can also check for a key, do a print line, and we can say something like, does it have a city key inside of it? And then we can say Paul map, and we're going to say contains key, and the key that we're looking for is city, and that's going to return true or false if that actually exists. We're also going to be able to come in and get the size of our map just by going Paul map, and you guessed it, size. And let's come over here and check out what we did, and there you can see all those things came back. And I think that's enough of a rundown of maps. We're going to revisit them here in a little bit, but now let's go and take a look at a range and how you would use it. Now, ranges are going to represent a range of values in a shorthand type of notation. So let's say we wanted to create a range of numbers from 1 to 10. We just go like this, and 1, dot, dot, and 10, and there you went and created it. You're also going to be able to create another one. Let's say we wanted to go from A to Z. You could also do that, and just type in an A, and a dot, dot, and a Z. And likewise, you would be able to come in and do this backwards. You could do the same thing with numbers, but letters are a little bit weirder, so I'm going to go and just do this and experiment, experiment, experiment. And there you go. That is how we generate a couple different types of ranges. Come in here and take a look at exactly how those all work out for us. So we could say 1 to 10. There we are. And you're going to see that it prints out all those letters and all those numbers and not just the 2 that we put inside of there. We can get a size for these different guys. So let's go and get a size for our range by just going 1 to 10 and calling the size function. We could get a specific index. So let's say that we wanted to get the second item in a range. We could do that. We could say 1 to 10. And we'll say get in this situation. We could check if a range contains a number. So we can say contains 11, for example. And let's do this for 1 to 10. And we'll just say contains. And then inside of the contains method, we'll throw what we're looking for. And we could get the last item inside of here. So get last. Let's just use 1 to 10 again. Get to. Don't throw anything inside of the get to. And that's going to give us our last function. And likewise, we're going to do if you want to do this in a different way, maybe another way that's going to work for us a little bit better, we could get the first item inside of a range by replacing get to with get from. And if we run all those functions, you're going to see exactly how they work out. There's the size, there's the second item. Does it contain 11? No, it doesn't. This is going to get us our last item in our range, and this is going to get us the first. So there's a rundown of ranges inside of Groovy. Now let's take a look at conditionals. Now the conditional operators inside of Groovy are going to be equals to, not equals to, greater than, less than, greater than or equal to, less than or equal to. There you go. There's all of them. You're also going to have some logical operators, and those are going to be and, or, and not. So there they are, and I'm going to show you some examples of exactly how they work. So let's go and define ourselves a variable, and this is going to be age old. Now with an if statement, we're going to be able to check if age old is equal to 5, and if it is, we can perform some calculations. And in this situation, what we're going to do is we're going to say go to kindergarten. Now, if age old is not equal to that, we will be able to say else if, just like you see in many other different programming languages, and let's combine this up. So we'll say age old greater than 5, and then we can do an and statement. That just means that both of these need to be true for the statements between the parentheses to be executed, and we can just say less than 18. So if both of those are true, in that situation we're going to say, well, let's go and use printf again. Printf's feeling lonely. We'll go to grade, and we're going to throw a decimal place inside of there and a new line inside of there, and we can perform a little calculation here that's age old minus 5. And then by default we can go and perform this last grouping of calculations, and in this situation we'll say print line, and go to college will be the answer there. Actually, infants would be told to go to college, I just realized, but that's okay. The infant's going to go to college as well, and you can see here go to 1 or go to grade 1 comes back because this is a 6. So that's a little bit of a rundown of the different conditional and logical operators. Let's look at a little bit more on them. Let's say that we create another function here, and this is going to be called can vote. You can also use booleans, which have a value of true or false inside of Groovy. And here is the ternary operator. So let's say that I wanted to come in and get one or another answer depending upon a condition. So the condition in this situation is going to be, is can vote a true or a false value? You can also put a condition in there, like we could say something like, if age old is greater than 5. What this is saying is, if this comes back as true, then I want it to say can vote to come back as an answer. Otherwise, if that or another condition comes back as false, I am going to say can't vote is going to be what I'm going to return. Close that off and close that off. Oh, give me a little bit of an error. Why did it give me an error? Oh, I know why it gave me an error, because I put this right here. Let's get rid of that right there. Execute again, and you can see can vote came back. Once again, this can be a condition, this can be whatever, and if that is true, it's going to come back with a value of can vote, or it's going to come back with whatever this is as true, and this if it is indeed false. And we also have the switch statement, and how the switch works is we can come in here and we can throw age old, for example, inside of here, and then we will perform different code depending upon if age old has a value of 16. So if it has a value of 16, we're going to say something like print line you can drive. We could also come in and go case 18, and we could say print line. Let's go and throw this on a new line here because I want to show something else that's kind of neat. So we'll say print line you lucky devil you can vote, and make sure you put this inside of quotes. And then we're going to throw a break statement in here. Now, if you do not put a break statement inside of here, it's going to check if age old is equal to 16, and it's going to do this, and then it's going to continue checking if it has a value of 18, and then do this. But what we're going to do is we're going to leave that out, and it's going to effectively check if age old is equal to 16 or 18. And then the default value If neither of these are true, it is going to be print line, and have fun is going to be the answer for that. And then if we come in and execute, you're going to see that have fun comes back right there. We can also do a list of options with switch statements. So we would be able to come in and go age old, and then do a case and say 0 between 6 if it has a value of 0 or 0 to 6. Well, then we can say print line, and the output for that would be child, and we'll throw a break statement in here on top of that. And let's go and do the same thing again for a couple more of these. Then we'll say if it has a value of 7 to 12, well, then we're going to say teenager. And it has a value of 13 to 18, we're going to say young adult. I don't know if that is a fact that you're a young adult at that age. Just throw it in there just for the heck of it. And then finally, default, and we'll say print line, and you are an adult otherwise. And there we are, child comes back. So there is a rundown of some conditional operators you can use inside of Groovy. Now let's take a look at looping. Now first thing I'm going to talk about is the while loop here. And with the while loop, you're going to go and define whatever you're going to be incrementing or decrementing or whatever with a while loop outside of the while loop. Then let's do something really simple, like let's say while I is less than 10, we want to continue doing some things. The very first thing we're going to do is we're going to use an if statement now that we know how to use conditionals, and we're going to say if I modulus 2. What this is going to do is if I is odd, it's going to skip back to the beginning of the loop, and I plus plus, that's going to increment, and then continue is going to skip back to the loop. So it's going to find out if I modulus 2 is equal to true. If it is going to increment the value, and then continue is going to jump back up here and ignore everything that comes afterwards. Otherwise, I can come in and let's say I want to use another one of these guys. If I is equal to 8, then I want to jump out of the loop altogether, and how I do that is I use my little break statement again. And if neither of those comes back as true, I am going to print some information out on the screen, which is going to be the value of I, and then I'm going to increment that. And with those handy dandy things, I can print out just my even numbers up to 6, and it doesn't print out 10 because the break jumps us out, and of course it doesn't print out our odd numbers because this guy right here takes care of that. So that's sort of a funky while loop that we can use inside of Groovy. Let's go and create something a little bit more simple, like a for loop. For loop's going to be very similar to what you've seen already. There's a couple different for loops, of course. Always has to be a couple different for loops. So we're going to define what we're going to be incrementing, how long we are going to be incrementing through this, and then we can just do a simple print line like that, and everything is self-encapsulated. Now let's go. We can also do another for loop that would work with range. So here we're going to say j in, and the range is going to be 2 through 6. And likewise, we can come in, do a print line, and in this situation throw a j inside of there. So that's sort of a shorthand way to use a range with a for loop. And we could also use a for loop with a list. So let's go and define a list. So we can say random list is equal to, and this would actually work with a string as well. You can do that for homework. And we could go random list and a print line and throw our j inside of there again. Could also use a for loop with a map. So let's come in and define customers. Put our little semicolon there at the end. And here with a list, we're going to go for, and it's going to be individual cust for the map cust to a print line right there. And we can say cust value if we want to get the value from it. And otherwise, we can say cust key. And if we execute all those, there you can see all of them print out quite nicely. So there's a rundown of ways we can loop. Now let's take a look at some methods or functions, if you will. Now methods are going to allow us to break our code into parts and also allow us to reuse our code. So what we're going to do is we're going to create a method here, and it's going to be called, or we're actually calling a method inside of here called say hello. And then outside of here, we're going to actually define it. And to do so, this is going to be a method that is going to be part of our class. So we're going to throw static inside of it. And we define our methods by using def again and say hello just like that. And here what we'll be able to do is go print line, and hello is just going to print out hello on the screen for us. So we're able to just call that function and hello prints out even though we called it from up here. Let's go and create something a little bit more sophisticated than that. Now what we're going to do is we're going to allow it to receive parameters, and we're also going to give those parameters default values. We can go define, and let's say we wanted to sum values. It gets passed two values and we're going to sum them. If you want to give it to default values, just go and put equals and whatever you want it to be inside of there. Number two, let's give this a default value of 0 as well. And then what we'll do is we'll just return num1 plus num2. And then up inside of here, inside of our main function, we're going to call this. So we'll just say, let's just do a print line just to keep it simple. And 5 plus 4 is equal to, and here we'll call the function just by calling it by name, and then pass in 5 and a 4. And if you execute it, you can see that it goes and sums those. So let's create even more complicated functions. Here I want to demonstrate that whenever you are passing values inside of Groovy, that you are actually passing by value. So what I'm going to do is I'm going to create a function here, and it's going to be called myName. So let's go throw a name inside of there. And I'm going to be calling a function called passByValue. And I'm going to pass my name inside of there. Make sure we put the right thing inside of there, of course. And then I'm going to verify that nothing changed, even though the value is going to try to be changed inside of the function. There's my name. Oh, let's go and get this and put this up inside of main. There we go. So that's what we're going to be checking. And once again, we're just verifying that we know that everything is going to be passed by value inside of Groovy, just like we have inside of Java. So pass by value is going to be the function, and here is going to be name. We're going to say name here, and we're going to call this in function just to make sure that the name has changed inside of here. And you're going to see that if I go and go name inside the function, that it's going to print in function whenever this is first called. However, whenever we go and go back here, it's going to print the original Derek. So nothing changed, even though the value inside of passByValue, or this method down here, supposedly changed that. Just remember, it's not passing the object itself, it's passing the value. That can cause a lot of errors if you forget that. Let's go and create some more functions here. Let's say that we wanted to both receive as well as return a list of values. So let's do something interesting. What we're going to do is we're going to double the list that is passed inside of here. So I'm going to get my list passed to this function. I'm going to go define new list is equal to. This is actually a closure. Collect, what it does is it performs a calculation on every item in my list. I'm going to do closures next. Just give you a little sample here just before we get to it. So what it's going to do, this is going to take each individual item inside of that list and multiply it times 2, and then it's going to return this new list. And we'll come up inside of here and execute it. So we're going to define a list. Let's call it list to double. 1, 2, 3, and 4. So there's our list. And let's go and pass list to double and then store inside of it the new list. So we'll call our little function called double list, and we'll pass list to double inside of it, and then we'll go and print out our new list. List to double. There we go. We went and passed in a list and we received a new list. We're also going to be able to pass in an unknown number of elements to a method. Define nums, and we're going to pass in sum all. 1, 2, 3, and 4. Print line, and this is just going to pass or sum an unknown number of numbers. How's that going to work? Well, down inside of here, we're going to get rid of this, of course, and sum all is the name of our function, and this is going to receive an unknown number of integers. So you're going to put 3 dots after that, and they're going to be stored in this numbered list. I'm going to define a function or a variable called sum. And then I'm going to perform a calculation on each item inside of it. This is another situation in which we have closure. We're going to use each here, and we're going to say sum plus equal to each of the items inside of that list. And then we will return sum back to it. If you execute this, you can see that it went and summed those values. And then we're going to show you for the final thing, we'll take a look at how we would calculate a factorial inside of Groovy. That's just the function that calls itself. So let's just go and call this factorial. This is a situation or an example of recursion. So this is going to receive a number. And then how you get factorial is if the number is less than or equal to 1, you're going to return a value of 1, and otherwise you're going to go and call the factorial function again. We're going to say return, and we're going to say num times, and this is the recursion part, or the recursion part, and you just get num minus 1, and save that. And up here inside of this guy, inside of main anyway, we can go, let's say we have factorial 4 is what we're calculating, so let's just call this factorial 4 is equal to factorial, call our function, and we'll pass 4 inside of there, and print line, factorial 4, and then output our final result. Save that, and there you can see it's 24. And if you're wondering exactly how that works out, this is an example of it. So the first time we come through here, it's going to have a value of 4, and that is then going to call factorial of 4 minus 1, which is 3. That's just jump us down here. Here's the 3. Factorial of 3 minus 1 is going to be equal to 2. That jumps us down here, so there's the 2. Factorial of 2 minus 1 is going to be equal to 1. This guy right here is going to kick back the value of 1. You can see the value of 1 right there. You can see 2 is right there. This 2 over here is going to jump up here. We're going to take the 3, this 6 is going to jump up here, and we're going to multiply it times the beginning 4, and that's how we get 24 with factorials. So there's a rundown of methods or functions inside of Groovy. Now let's take a look at closures. Now a closure is going to represent blocks of code that can accept parameters and can be passed into methods. Now let's actually, just to be interesting here, let's create an alternative factorial using a closure versus what we previously did with just a method. So how we would do that is we would define, and let's say we want to call this get factorial, going to be equal to num is going to represent a parameter passed into our closure. Then what we're going to do is we are going to just basically structure everything exactly like we did with our function. So we're going to say if num is less than or equal to 1, well, if that is true, we're going to return a value of 1. Then we're going to come in and go num times call is actually going to call our function once again, the get factorial function, and we're going to pass num minus 1 inside of there. So there you go. You just created a factorial. Now what we're going to do is go print line factorial 4, and we can go get factorial 4 and save it and execute it, and you can see that we got the same 24 using this closure design versus the method that made us jump all over the place. Okay, so kind of cool. Experiment with closures, they're a lot of fun. Another thing that's neat about a closure is it's going to be able to access values outside of it. So let's say we have something like define greeting, and this is going to be goodbye. So this is stored outside of the closure. Now let's go and define a closure that says say goodbye. So we can say goodbye equal to, and it's going to receive a name. So let's just call it the name. And what it's going to do with that name is it's going to say print line, and it's going to come in here and it's going to get the greeting that is defined outside of the closure, and then it's going to also include the name. And then we'll be able to call it just by saying say goodbye and throw in the value of Derek, and there you go, goodbye Derek. So another example of closures, kind of neat. They're very commonly used to perform operations on each item in a list, as you saw previously. Remember I said I would get back to this. So here is a number list, 1, 2, 3, and 4. We're going to be able to perform a calculation on each one of these guys, or in this situation I'm just going to print them out. Showed you a calculation last time. So here we can go print line and print out each of those items in that list, and there you can see those are. Likewise, we could do the same thing with a map. So let's define employees and just throw some employee data inside of there. And we can say employees each, and we could do, just print this out on the screen as well. We can just go IT, and let's say we want to get the key, and then IT, and we want to get the value off of this. And there you can see that is. We're also, let's go and create another one of these. Let's go random nums, do something a little bit more interesting. Create a list. Let's say we want to print only the even numbers. So we'll go random numbers and each, and we're going to get each of those individual number items. And we'll say if num modulus 2 is equal to 0. Well, then we want to print it out. Otherwise, we do not want to print it out. And there you can see it prints out only the even numbers. Find is another function like each that's going to return a match. So let's say we have a name list, and we'll say match element is going to be equal to, throw name list inside of there, followed by find, and here we'll say item equal to Sue, and then we can print out that information if we'd like. So we'll say match element. And you can see that Sue comes back as a result because it was found inside of that list. Find all is going to find all matches. So we'll say something like random num list, and we'll say 1, 2, 3, 4, 5, and 6. And define number of matches is equal to random number list, and we'll say find all. And we'll be able to do something a little bit more sophisticated here. We'll be able to get each of those individual items and match if the item has a value greater than 4. So you can do all kinds of different things here. And print out the number of matches we have, and 5 and 6 both come back as a result of that. Any is going to check if any item is going to match. Let's just throw this right inside of a print line just so you can see that we can do things like that. So we'll say greater than 5, random number list, and any, and then we could throw item inside of there, and item greater than 5. Every, on the other hand, is going to check every item in the list. Let's just go and copy this print line here. So in this situation, we'll say greater than 1, and we'll change any into every, and we'll change this to a 1, and you can see this comes back as true and this comes back as false. Collect, and we saw collect earlier, is going to perform operations on every line. So let's just go and paste in a print line here again, and here we're going to say that we want to double everything in a list. We're going to double random number list, and this is going to be collect, and here item, and what we're going to do here is we're going to multiply every item in the list times 2. And there you can see it doubled all those guys. And also we're going to be able to pass a closure to a method. So let's say we create a closure, and it's going to be called getEven. And we can say num, which is the parameter it receives, and then it's going to return num modulus 2 equal to 0. We're then going to come down here and go define even nums is going to be equal to list edit is going to be a function I'm going to create here in a second, and we're going to pass in a random number list to it, and also we're going to pass in our closure. And then after that we're going to print out some results, and this is just going to be all of the even numbers that are going to be returned, even nums. Let's jump down and create that method down here. Here is the function static define list edit. It's going to receive a list and the closure, and it's just going to return list, and it's going to go find all closure, and there you can see it went and doubled all those up. So pretty cool things we can do with closures. Now let's take a look at file IO. Now I have a file up here called test.txt, and you can see exactly what's inside of it. I'm going to come in here. First I'm going to open a file and read each line and output them. How I do that is I go new file and provide whatever the name of the file is. So there it is, test text. And then I can go each line, and then I can say exactly what I want it to do. In this situation, I want each line of text that is read in from here to just simply be printed on the screen. So pretty simple stuff. And there you can see that it went and did that. So that was pretty simple. Now let's say I want to overwrite our file. Well, I just go new file, test, text, and this is overwriting it. That means I'm eliminating what's already there. Here I'm going to say that I want to use UTF for writing information to our file. And then I'm going to say writer, write line. And here I'm going to say line 4. Prints out what it originally was there, but if we come over here, you're going to see that everything's been overwritten with line 4. So kind of mean. Got rid of all that hard work. We went in there. We could also append to the file, and we could also go file is equal to new file object. And here what we're going to do is we're going to say test text, and then we'll be reusing this, guys. We can say file. Here we want to append, And here we can put line 5, for example. Line 4, and you can see line 5 is there now. We're also going to be able to get the file as a string. So we'll just do a print line, and we can just go file, text. That's going to give us the whole entire file as a string, and we could either print it out or we can go and store it in a string or do whatever you want with it. We'd be able to also get the file size. So we can say this, file size, and file length in this situation, and this is going to be in bytes. That's what's going to be returned to us. In this situation we have to put our little curly brackets around this, and there you can see it comes back, it's 13 bytes. We could also check if a file is a file or is it a directory, and for that you're just going to put in file and then followed by is file or is directory. It comes back as either true or false. We'd also be able to come in and copy a file to another file. So we could say new file is equal to new file and create that test2 text. And then to copy it, we can go new file and file text. And and you can see right there, test2 shows up. And if we open it, you can see there it is because we went and copied that information over to it. Of course, we can come in and delete a file. We can go new file, delete, and that's going to delete it. And also get a directory of files. So say directory files is equal to new file and list roots, and then cycle through all of those different results that we receive with directory files each, and then output each individual item that we receive. Print line, and you'd go file, absolute path. There you go. So that's a whole bunch of different things you can do file I/O wise. Now to finish off everything, I'm going to jump over and show you how object-oriented programming works in Groovy. Now, just like all other object-oriented programming languages, classes are blueprints that are going to be used to define objects, and every object is going to have attributes, which are called fields, and capabilities that are called methods. Now, if we want to create some objects, what we have to do is come in and define some objects. So I'm going to come in here and I'm going to create an animal object that we can work with. And I'm going to first off come in and go import Groovy transform and toString. This is a toString method that I want to use here. And if you want a method automatically generated called toString that's going to output some information about your classes, all you have to do is import that and then go to string, and the information that it outputs whenever this is called. If you want the names to show up, you would just go exactly like that, include names true. And if you want the fields to show up, you can go include fields and also pass the value of true. You're going to see here in a second exactly how that works for us. Now to define our class animal, I'm just going to go class animal right like this. We can define some fields that all of our animal objects are going to have. So let's say every animal object is going to have a name as well as a sound. Well, there you go. You just define them. You can define the methods or capabilities of these guys. So let's say every animal is going to have the ability to run. Well, there you go. You can do that. Also going to, let's just throw this in here. If you want to reference the name of our object, you can just go name and follow that up with runs. Could also, let's say that every animal is also going to be able to make a sound. We can make a sound like this, call this method, and here we'll just go print line and name says, and then throw sound inside of here. And then also we can create a constructor so that whenever the animal object is created, you're going to be able to pass in a name and a sound, and it's going to be automatically created for us. If you want to reference the actual object's name, you use this like you do in many other programming languages, and the same with both of those attributes. And let's leave that as sound, and there you go. So there's a rundown of all the different things you can do with those classes. Now let's go and create an object back over here. Let's say we want to create an animal object, and we'll call it king. Well, all we need to do is go new, call the constructor that we want to call here. Now, if the constructor didn't exist, we could come in here and define these with what are called named parameters. So I would come in here and type in name, followed by whatever the value of name would be. And then I would type in sound, followed by with whatever the sound would be. But since we have a constructor inside of here, we're not going to do this part. We're just going to come in instead. Let's go and get rid of that. And we're instead going to come in and just simply type in king like this, separate it from this. And this is going to create a new animal object and call the constructor and create that object for us. We can come in and print some information out on our screen for us. So let's say we wanted to go and get king name says king sound. Save that. And you can see king says growl. So it called that, or got the attributes for us there and printed those out on the screen. We're also going to be able to change an object attribute with a setter function. They're automatically created, and they are set followed by whatever the name of the attribute is. So let's say we want to change it to grr. Well, there you go. You just change that. We'd then be able to go print line, and once again, king name says king sound. And also we can of course call the functions that or the methods inside of there. So there's the run method that is defined for our animal objects, and there that is. Oh, and I also told you that I would show you exactly what the toString thing does for us. We can go toString. Well, we're actually going to have to go print line. There we go. That, like that, like that, and that. And this is what print line does for us. It prints out the attributes and the values for them. Now with inheritance, a class is going to inherit all the fields and methods of another class. So what we're going to do is we're going to create a dog object over here. So if we want our dog class to get all the attributes and methods from the animal class, just to go and extend it, and then we can say define owner. We can define a new constructor for our dog objects by going define dog. And let's say we're going to get our name and our sound and our owner all passed into this dog constructor. We would be able to call the super or the animal class we inherited from its constructor and pass in the name and sound to let it handle adding those in. And otherwise we can come in and just go this and owner right like that. We're also going to be able to overwrite different methods inside of here if we'd like to. So make sound and throw that inside of there and print line. And then if we want to print out the name, says bark and sound, we can do that and save that and jump back over here and then define a dog object. Let's call it Grover is equal to new dog Grover and Gur, and Derek is the owner of the dog. And then we can show the difference here, make sound versus the Grover dog object, and we'll save that. And there you can see king says Gur and Grover says bark and Gur. Alrighty guys, well I was gonna cover a little bit on inheritance and exception handling and so forth and so on, but this video's gotten really long and I think I covered a heck of a lot. Love to know if anybody watched the whole entire video out there. Please leave a comment if you did. I would greatly appreciate it just to find out how long people strung along. But if you want to see a really quick example of exception handling and a little bit more on object-oriented programming, like I said, in the link in the description, I'll make sure I include all that information. And just like always, thank you for everybody tuning in, and please leave your questions and comments below. Otherwise, till next time.